Welcome along. Today we're going to be talking about the library that is going to give you confidence to make that refactoring or those rewrites of code and deploy to the production with more confidence than you ever had. This is a library that I used several times in the past, and we use it in one of my companies to make a rewrite of an extremely sensitive piece of code. The example that I'm going to give you now kind of matches what we did at the moment, and basically what we wanted is to move technologies. We wanted to move data that was being stored in SQL. We wanted to store it in NoSQL. So what we decided is doing dual writes. So at the same time that we store in SQL, we were also going to fall back to store on NoSQL. And what we wanted is that when we show the data back to the customer, we were sure that everything that was written was correctly, and it matched bit by bit to what was in SQL than what is now on NoSQL. Why we choose to use this library? Because it will give us confidence that we can do a transition without doing a big bang and losing data. What happens if you decide to do this and you don't run in parallel? You might be storing new data on SQL that it's not correct, and then you have to switch back to SQL and you lost a lot of data because it's in the new system but it's not on the old system. So we decided to do this dual write and use scientists to compare the data we are sending back to the customers. At the same time, we were doing also analysis in the databases in SQL and NoSQL to see that the data matches, but we got a lot of confidence putting scientists and comparing that what we were doing was exactly what we wanted. So the library is called scientist.net. It allows you to basically create an experiment and runs two different pieces of code, and it will compare the result, and it will say if the experiment was successful, if the result matches or not. Why is it good, this library? Because it will randomize the order in which runs the experiment and the different candidates. You can have different tries if you want to experiment different ways of doing things. It will give you ways of deciding when to run and when not to run the experiment. If it's already a certain level of confidence, you can stop running, or if you see that you're getting a lot of errors, you stop running the experiment. So you, if your experiment is taking a lot of time, you can basically on the fly stop doing it. Let's go and dig into the code. So let's imagine that, like what we did, is we have our users repository that returns a user and it's implemented on SQL. Here we have two users, one with an MKD and one with ID finishing 1. The name is SQL. Now you deploy infrastructure on NoSQL. It could be Mongo, it could be Cassandra, it could be anything that you want. You implement your repo, and by some reason that you still don't know, some of the data there is corrupted. But you cannot assess this with integration testing, you cannot assess this with acceptance testing or any other way. You go to production and you start seeing these problems. So if you use this tool and you run the code in parallel for a certain time, you completely minimize this risk. Let's see how we can use it in order for us to be more confident while doing refactoring. The first thing that we're going to do is we are going to install the scientist NuGet package. The other NuGet package that I'm going to suggest to install is publishers.serilog, so we can see what's happening, and I will explain you why now. As we have implemented our SQL and NoSQL repo, what I'm going to do is I'm going to add a new science repository. Science repository that is going to implement the users interface. And what we're going to do here is we are going to inject a scientist. We are going to inject our SQL repo. We are going to inject our NoSQL repo. And what we're going to do is we are going to return an experiment that returns a user. We're going to give this a name because you can run as many experiments as you want in your code for different parts of your code base. And now we're going to configure the experiment. How we configure the experiment? Well, we're going to say that it needs to use as the base case, which is what you're doing at the moment. We're going to use SQL get by ID. And we're going to tell the scientists to try our new way of doing things. NoSQL get by ID. And that's it. Basically, we just created an experiment, and this library is going to perform comparison in memory randomly of the different execution paths. What we need to do is we need to configure the dependency injection engine. For that, I'm going to copy the code and just configure here. What I'm going to do is I'm going to replace my repo to use the science repo, and I'm gonna also inject my NoSQL repo and my SQL repo. Okay. So now that we have scientists and we have changed our repo to science repo, I'm going to explain what this result publisher is. Basically, every time that an experiment is run, the library will publish those results into a result publisher. We have installed this library called publisher Serilog that is going to get the information in memory and is going to send it to Serilog. I have configured Serilog to write to sec. If you don't know what sec is, let me know in the comments and I will create a video about sec and how you can configure and run it in .NET with Docker. So now that we have configured everything, we can run our experiment and see how it goes. Okay, we see that we are returning a user and we see that we have a result published here. Let's see what it says. We say that there is a mismatch. Our control case is first name test, first name user, first name and last name, everything matches. So what's going on here? Let's go back to the code and understand what's happening. When we do an experiment, the library is going to compare in memory what is the result of both of them. Because there are different instances in memory, the experiment is failing. So there are two things that we can do. One is we can go to our model and we can implement an equatable interface, and from now on our experiment should succeed. Let's see what's the last result. There is a match, but what happens if you don't want to do this? So we are not going to implement the equatable interface. At this moment, our experiment is going to fail. But why if everything is exactly the same? What we can do is we can say that it will use to compare this lambda function that receives for each candidate that we run a comparison on a specific field or whatever thing that we want to compare. Now let's run the experiment. And we'll see that the new experiment, there is a match. I'm going to delete this. I'm going to show you again that if I remove the comparison, our experiment is going to fail. We have an experiment. It fails. I'm going to use the comparison. And you will see that there is a new result here and the comparison doesn't fail anymore. So again, the library allows you to create a comparison as a specific function for you to determine whether your experiment is successful or not. What other things can you do with this? Basically, you can tell to the experiment to run under certain conditions only. For example, we are going to run it only if the ID is not empty. Let's imagine that our ID empty is just for admin users. We don't want to run experiments for admin users because we already know that that's not a problem. Because we are running an async experiment, we have to provide a conditional a function that returns a task. So now we're only going to run experiments if the ID that we're passing here is not empty. Okay, so what I'm going to do is I'm going to clean up the log. There is nothing here. I'm going to run my app that is going to request for the user with ID 0, and we see that nothing happens here. Now if I request the user with ID 1, we can see that we have a result, and it's mismatched. Now, what else can we do with the experiment? We can add to the experiment some context, and we can say, for example, the user ID is ID. Let's see what we have here. We have an empty context. Now I add a property to our context, and I run the experiment. It's not running because it's set to run only if the ID is not empty. When we run the new experiment, we have something in the context. So this can allow us to filter better and get better data and insights on our experiments. So this has been scientist.net. This is an amazing library. I'm gonna leave the link below in the comments. If you want to know more about .NET, how I set up Serilog with sec to run and to plug into my solution, let me know in the comments. Let me know if you have used Scientist before and how to use it. Happy coding, everybody.